Okay guys, for you to further understand how my boiler or the burner is operated, I'm going to discuss with you the chart burner operations and the fuel oil circulation systems. As you can see here, there are auxiliary systems of the burner that need to be actuated, operated, or satisfied within a given period of time during a boiler or a burner is being started and operated. On the starting phase, you can see here, once the boiler is started, the forced draft fan and the fuel oil pump is started simultaneously. The fuel oil pump is running, the forced draft fan is also running, and then it has a 60-second period to do a pre-purging time sequence. Once the 60-second pre-purging time sequence is attained, that's the time for the pilot burner and high voltage electrode transformer is being energized at the same time. As you may take a look at it, the spark for the high voltage ignition transformer about 10,000 volts will be energized. Both of them are energized within a period of 10 seconds. While building up a ignition flame within seconds elapsed, the main shaft magnetic valve will be energized to give a pressurized jet fuel on the main burner. And then the flame eye also sensing a flame 10 seconds time. This flame eye sensor must need to satisfy a presence of flame inside of the furnace. This is the damper from which within 60-second period the damper is open, and then once the flame sensor is detected that there is a flame, it will give signal to the damper, energize the solenoid actuator and close the air. Seconds, and then open again the air damper whether the pressurized jet is injected on the main burner. On that period, the pilot burner and the spark electrode is in off. The draft fan is continuously operating. The plug is switching energized to make spark inside of the furnace to get the continuous burning is ongoing. And from down, you can see here the fuel oil heater and the fuel oil pump. This fuel oil heater is started running it will switch off and then running again to maintain the fuel oil temperature. This fuel oil pump is also stop, running, stop and running while doing the automatic operation starting on and starting off of my fuel burner boiler. This is how a chart of burner operation and the fuel oil circulation system is working with my boiler system. Okay guys, what I have here is about the final flow chart process of the boiler. This operational flow chart process of the boiler is divided in 4 sections. The first section is the safety alarm, trips, and interlock system when there is some abnormalities with your boiler system. As you can see here, this safety alarm, trips, and some abnormalities condition of the boiler state the alarm for ignition failure flame, the force draft fan and pump stop alarm, the water level lowest alarm, the fuel oil low temperature alarm, and the fuel oil low pressure alarm. This pressure and temperature low alarm, water level low alarm, fire fan pump stop alarm, and ignition flame failure alarm, and the emergency stop switch will give a safety interlock with the boiler. Having these alarms, you are no longer start the boiler in automatic mode. The second section of this flowchart diagram is the automatic starting phase and running phase of the boiler. From here, going here, program start, fire damper fan, air damper shut, pilot burner on off fuel valve open, pilot burner off, program lock in, and continuous burning. This process, continuous burning, burner switch on, program start, is a second phase of the flowchart process, wherein a boiler is functioning in a normal way. The third section is the purging and cooling process. Is stop or extinguish, it requires a purging process wherein the fuel oil pump and the fuel oil valve
The energize, stop and close, and within
force purging by continue operating the force draft fan. After finishing the post purging, the force draft fan, and cools down the system, the force draft fan will stop. My fourth section is a section from which a boiler system will proceed on a standby mode. On the standby mode, it will wait until the pressure drops about
About
0.49,
0.47 megapascal.
and then the boiler will automatically start again from the beginning. For you to understand, I will explain to you a little bit on how the boiler is automatically start and automatically stop, then again automatically start. Okay, since my boiler is designed to have a maximum steam pressure about 0.59 megapascal, and it will started on when the pressure
Between 0.47 to 0.49 megapascal.
the automatic operation of the boiler will begin by means of programmable logic controller sequencer module. This programmable logic controller sequencer module are found inside of the boiler control panel. As you can see here, this is my programmable logic controller sequencer, Sysmap CQM1H, CQM1 ITSC, made by Omron. This is my PLC unit from which the program time period in executing and giving a signal on a certain boiler auxiliary system is being based on the program made on this PLC sequencer module. Take note, the automatic starting on and starting off of my boiler is made possible by using a PLC programmable logic controller sequencer. On board chip, I'm using a Sysmap CQM1H CQM1 ITSC ID controller made by Omron. Okay, this process flow chart of the boiler is pre-PLC sequencer module. To start with, since my boiler is programmed having a maximum pressure of 0.59 megapascal, and this pressure, steam pressure drops about
0.47 megapascal.
The mode selector switch of my boiler are in automatic mode. My pressure transmitter will detect the lowering of the pressure of my steam. If the steam will become less
0.47 megapascal.
boiler
Pressure
burner
switch will close and
automatically switch on. Once it is switched on, start. Meaning, the programmable logic controller will give an output signal to command all the auxiliary devices on my boiler to do a process and produce a continuous fire. Once it is on, the program start. The fuel oil pump is started, and the force draft fan is also started. Once the fuel oil pump start, it will mix and brings the fuel from heavy fuel oil tank going to the pipeline of the main burner, and the first draft fan is running and perform a pre-purging time within 60 seconds. While the pre-purging time is performed, the air damper is open. Then, the PLC sequencer or the logic controller counts about 60 seconds. When the time 60 seconds is finished, the air damper will be closed or shut. That's the time that the PLC logic sequencer give a signal for a pipe pump to switch it on. We also command the electrode to ignite the pilot burner within 10-second period time, and as you can see here, there is a black arrow. This flame eye sensor means it needs a counting time within 10 seconds to sense the presence of flame inside of my furnace. Once it is detected that there is a flame on my furnace, it automatically gives signal
To the PLC,
to
and the PLC will command the fire damper to close within 1 second, and after closing within 1 second, and a detector verifies that there is a flame on the furnace of the burner, it will open again, and the PLC are continuously giving signal to the solenoid valve to give, energize, and allow a high pressurized jet fuel to enter on my main burner. And once the flame are established on the burner,
be initiated. Once the program lock-in is initiated and there is a continuous fire inside of my furnace, this burning will goes on until the steam pressure on my boiler
within
is
0.59 to 0.62 megapascal is attained. This condition gives for a pressure switch to give signal on the PLC controller and
to automatically shut off the fuel oil pump. The fuel oil pump will stop, and then the fuel oil valve from the return of the main burner pipeline will be de-energized, and it will cut off the fuel on my boiler furnace. Once the fuel is cut off, the fire or flame inside of burner furnace will be disappeared. Once this is disappeared, a prep will be initiated to continuously run and count within 60 seconds. First draft fan within 60 seconds, a cooling down and post purging process, so that all the accumulated combustible gas or explosive gas inside of the burner, inside of it, will be thrown on the atmosphere, and then after six months will automatically stop itself. On that condition, the PLC programmable logic controller sequencer is proceed and makes my boiler on a standby mode. This standby mode takes more time until the steam pressure again drops from
0.62 megapascal lower to 0.47 megapascal.
My steam
Pressure switch
transmitter
and pressure transmitter control and monitor
pressure is dropping by about 0.4.
0.47 megapascal. The pressure switch gives a signal.
PLC input and output logic controller PLC sequencer to start again my boiler, and the program
Will
will
again.
my boiler is working in automatic mode. Take note, the automatic mode is made possible by using a programmable logic controller sequencer. What I have here is the electrical wiring diagram of my boiler, and I'm going to explain to you how this boiler is operated in automatic mode by the help of electrical instrument devices and programmable logic circuits sequencer. Automatic mode that keep it within the system is the PLC, what you call the programmable logic controller. To begin with, here have the PLC having an input 00, 01, 02, 03 up to 13, and connected here 14 and 15. Central Processing Unit CPU 11 ME04K, and here I have 008 channel, and here I have 001 channel. This is my PLC input, and also here I have the PLC output. PLC output, we have 100H, 100 with the supply, terminal 10, and negative on terminal. This PLC output module has a channel from 1 to 13, and from 13, 14, then we have 16, 17, 18, which is unused, not used, 20 and 19, going to the positive and negative supply on other circuits. Also, I have here the PLC output module. This is the output unit 0D213 out 101 channel, from which all the indicator lines are being connected for the flame present, ignition flame pin, fire damper fan, force draft fan grip, high water level, low water level, lowest water level, low oil pressure, oil temperature, high oil temperature, emergency stop, and maintenance operation, limit switches open up to output 13, 14, thermostat bypass. This is my PLC 1, 2, 3, and here I have my hardwired electrical connections. From here you will see the R1 and T1. This R1 and T1 is a supply from this transformer having 100 volts. Here you will see the fuel heater, the force draft fan, the fuel oil pump, the pilot burner pump. And from here you will see some relays, coil relay, some devices, some contacts, from which you will find how the boiler is operated in a automatic mode by the help of the programmable logic controller sequencer. To begin with, the boiler control panel, as you can see here, and from here there is a lot of switch and manual operation switch. I'm discussing now the automatic operation mode of the boiler. To begin with, we must need to switch on the boiler circuit breaker so that the source is illuminated, and we need to put the burner stop button into automatic position. If this is done, the programmable logic controller input are now in standby mode, waiting for the signal to be in the pressure switch to do a burner on or a burner off operation. As you would take
0.69 megapascal, and it will stop at 0.59 to 0.62 megapascal and started at 0.47 megapascal. Drops by 0.47 megapascal. Pressure switch monitor will close. When this is closed, unit have positive supply going to the common and negative contacts on these devices. Once contact is closed, it will send signal on this PLC 00CH input terminal number 10. Once this is initiated, the program will begin, and this CPU, Central Processing Unit, will give a signal for the 100CH PLC output to start signal, send signal on terminal 1. Since this is in automatic mode, it will energize the relay FX. This 88FX has going to the close. See, the is energized. My 51F of my 88 my force draft fan is closed. Once this 88FX will close, this 51FX is also closed because this is energized. This 88FX relay for my force draft fan 2.2 kilowatt 88F contactor will close, and this motor for the force draft fan will be started. While this force draft fan is started, this output PLC sequencer module also give a signal on terminal 14 to start my view signal on terminal 14. The 88QX electronic relay will be energized. Once this is energized, my fuel oil pump having overload relay 5110, which is normally closed. This 88Q will be energized since this 88QX contacts of relay the auxiliary 88QX, which is energized by the PLC output on terminal 14. This 88Q main contactor relay of the fuel oil pump is also started, and you can see here this is the 88Q contactors. This fuel oil pump 0.75 kilowatts
will also started. Almost simultaneously with the fuel oil pump
for my
475
main
kilowatt.
burners.
It will take oil from the tank and deliver to the pipeline of the main burner pump. And the force truck pump, while it's running, it will do the what you call post-purging. This post-purging, it takes about 60 seconds. Okay? And then, this PLC sequencer will give signal to the electronic relay PBX. This PBX electronic relay is already energized, giving a signal from the PLC signal to this PBX electronic relay
Has auxiliary contact
the
going to pilot burner
auxiliary
pump,
contact.
ignition transformer, and energize it.
Is energized and ignited the fuel delivered by the pilot burner pump. This output counts from 0 to 10 seconds from flame detector module counts about 10 seconds inside the furnace, and if detected that there is a flame inside the furnace, the contact 4 and contact 5 will be closed. Once this contact is closed, this FDRX electronic relay will be energized. Once this electronic relay is energized, because the contacts of the flame detector from 4 to 5 is closed, this has auxiliary contact going to the
PLC input port
solenoid
and solenoid valve.
with relay 21QX will be
And then,
switch
this solenoid valve
energized.
will be energized since the auxiliary contact of the FDRX relay will be closed from the flame eye sensor FDRX electronic relay. Once a solenoid valve is energized, it will open and will allow a high pressurized jet fuel be injected on my burner system.
Give signal to the air damper solenoid valve to close the air damper by about 2 seconds, and then after 2 seconds this air damper solenoid will be de-energized again
To feed air inside of the furnace,
after having been furnace inside of my boiler has building side of my burner. Once the control valve is on fire inside of my furnace burner, the PLC CPU is off within 10 seconds, and the ignition the control valve program will lock in. My is again monitoring the steam pressure of my boiler. If the steam pressure reach about 0.59 megapascal,
megapascal,
releasing the switch, it gives again sequencer will give again a signal to control valve on off. After the energizing this, when on the furnace and the boiler burning process will stop. But the forced draft fan are still running, and this PLC module will count about 10 seconds is accomplished within 60 seconds or 10 minutes. This CH output
integrated with on delay PLC OD213 module.
On the terminal 1 to the energize the ATFX electronic relay. Once this is energized, this 88FX, this 88F magnet main of my draft fan will open, and this forced draft fan motor will stop. This is how switching on and switching off of my boiler is operating.
Okay guys, this is my boiler control panel. As you can see here, there is my source indicator light. This is a yellow color light, and I have the red color indicator light for ignition flame failure. This green light is the flame reset indication. The red one is the forced draft fan trip, and this is a thermostat bypass. This is the orange light. This is the emergency light. This is my high water level alarm, and that is my high oil temperature alarm. This is my lower water level alarm. This is low oil temperature alarm. This is lowest water level alarm, and this is the lower oil pressure switch alarm. If the pressure drops from 2.2 to 1.86 megapascal. Here is the pressure transmitter from which pressure indicator on the engine control room are taking a signal of it. We are now here in the engine room. As you can see, there is a 0.5 megapascal with a time of 13:37. Now we are going to verify and observe if the automatic starting of the boiler will be made by having a pressure of about 0.47 or 0.49 megapascal. From now, the pressure is about 0.48 megapascal, and we are observing if the boiler will be started if the pressure will drop by 0.47, and this boiler will be started itself. Now we are counting, and as we count here, we have now 0.47.5. We are still here, and we will find if this boiler during a normal condition will start himself automatically. As you can see, we are counting. As you will observe, the boiler is started automatic, and we verified that the boiler will be started by 0.47 megapascal. Now we are here in the boiler plant system area. As you can see, the boiler is running and started himself, having a pressure drops by 0.47. This is my flame. The pressure here is about 0.58 megapascal. And from the engine room, you will see the pressure about 0.58 megapascal. Now, as you will see on my burner panel, a flame preset is indicated. A temperature of my fuel are maintained. This is the fuel electric heater. This maintains a fuel by about 90 degrees Celsius. And this is my pilot burner having 0.45 megapascal pressure once it's started and ignited by a high voltage ignition transformer. It is switched off when the fire is already established. This is the main valve shut off of boiler fuel main burner supply, from which the fuel is heated on 4 kilowatts electric heater, maintain a fuel temperature by 90 degrees Celsius, and supply a fuel to feed a fuel and maintaining a flame or fire inside of the boiler. This is my fuel going into my main burner assembly. This is the solenoid valve from which it is open to allow a high pressurized fuel jet to penetrate inside of the main burner. This is my return pipeline from which some of the fuel will goes to the main burner while this solenoid valve is energized, and another or some fuel will proceed and return on the tanks. This is the pressure gauge of my fuel burner having 2.2 megapascal or 22 bars. My boiler steam pressure is continued to rise and increase while a boiler burner is operating, and as you will see inside of the control panel, I have the pilot bank, the energized, and the force draft fan and fuel oil pump. Both of them are engaged and energized. While a burner is running, this electric heater relay will switching off and switching on by means of this temperature controller Omron SD-C15. And here, you can find here the programmable logic sequencer from which the automatic switching on and off of the boiler is depends on this supervised monitor and do a commands to instrumentation, electrical and electronic devices to execute a given orders and command to perform a process and make auto start and stop of boiler based on a program time set values on PLC input and devices. As you can see, this PLC sequencer has a big role for auto starting and auto stopping of the boiler. This is the air damper and it will keep open as you would see when the boiler is continue running.
Air damper actuator. This is the air damper, and this is my transformer type actuator. One transformer here is energized, it will pull these counterweights. Once this will pull, it will close the air damper. As you can see here, once the counterweight is pulled, the air damper is closed, and by 90 degrees, when this is re-energized, the counterweight will fall down and the air damper will be open.
While the air damper is open, a force draft fan is run continuously while the boiler is operating, and while the boiler is stopped, this force draft fan will continue running to perform a purging process. Here is the PLC model CQ M1H CPU having input of 24 volts with 16 milliampere. Here you can see the PLC channel input light on indications, means the devices connected on each are active and activated. And here you can find a channel input devices lights on during a boiler is in operating. 00 channel means flame present, 01 for forced draft pan, 02 for burner auto, 03 for reset, 06 for thermostat bypass, 07 for pressure switch low fuel trip, 08 for high oil temperature trip, 10 for steam pressure switch burner on, 11 for fuel oil heater on, 12 for high water level on, 13 low water level on, 14 lowest water level on, and 15 for lowest water level on. As you observe, the input channel 12 light is switching on and off, meaning the water level of the drum is being monitored. If the steam pressure of the boiler is about 0.62 megapascal, the PLC input channel number 10 light will be off. The boiler now is off. As you will see here, there is no flame inside. The first draft pan is still running. To finish a 60-second purging period, the air damper are still open. The rightmost PLC on delay timer 213 counting within 60 seconds period to switch off the first draft pan and a main burner fuel pump. Now you can see the first draft pan is out, de-energized. The fuel oil pump is de-energized. And here, as you will see, the input channel 00 for flame preset light is off, and the input channel 01 for forced draft pan trip is also light off. As you can see, now the forced draft pan, fuel oil pump, and a pilot burner pump all are de-energized. This fuel heater relay with switching off and on while maintaining a temperature of the fuel. A thermostat bypass is lighted, and this forced draft pan is already off, and we will find the steam pressure of my boiler is now dropping from 0.62 to 0.5, and this flame present indicated on the engine control room are now extinguished, and now we are observing the pressure to be lowered from 0.62 to 0.58, and now we are going to wait until the pressure will drop by 0.47, and this flame preset will be activated if the boiler will start again.